I've just got another question. I think that's what everybody wants to know as well. What's the mechanism of COVID? How do we get it? And if you know, like long COVID mechanism, if you can tell us too as well. Thank you.
Yeah, well, unfortunately, like with everything about long COVID, there's no simple answer to that question. What we So there's a whole series of different things that have been seen immunopathologically that people think may explain why you might get persistent symptoms. So one of the big questions is, does the virus persist in the body? And a number of studies have looked at various organs throughout the body and in fact have been able to demonstrate months and months after infection that there's viral RNA in multiple organs, in the brain, in the adrenals, in the myocardium, in the lymph nodes, in the intestine. So I think viral persistence is certainly playing a role. There's been a suggestion that spike protein itself can damage the cardiovascular system and neurological respiratory systems. The actual spike protein can be having local sort of toxic effects. But the other thing is just immunological effects in general. Now, whether that's due to the persistent virus and it's thought that that might cause circulating immune complexes to which you then get immune activation, but certainly ongoing and persistent immune activation is very typical of COVID. So that immune activation leads to chronic inflammation and the release of cytokines, sort of pro-inflammatory cytokines that go with that. And we know that chronic inflammation is a bad thing. If you're pro-inflammatory, it's not good. So you've got higher levels of things like IL-6 and TNF and interferon gamma. So studies have shown, looking at biomarkers in the blood have tried to see if they can actually see which ones might actually be raised. The T cell responses have become abnormal. The immune cell populations are different. So the myeloid and the lymphoid circulating populations are different. So all of those things obviously lead then to a dysregulated immune system. Whether that's being driven by the virus that's persistent or not isn't quite clear at the moment. The endothelium becomes dysfunctional and that can lead to hypercoagulability. So, more able to cause clots in the body and that, of course, can cause end organ problems. But then there are other things. So there's autoimmunity that can be triggered by this virus. And we know that there's a lot of parts of the virus are cross-reactive with other epitopes, so they can actually trigger autoimmunity and autoantibodies to get released. And that, again, can cause inflammation and can cause joint pains and end organ damage as well. And the autonomic nervous system seems to become dysfunctional as well. So a number of people develop syndromes where they drop their blood pressure and various things. So that can be associated with COVID itself as well and with the vaccine, but can also be a feature of long COVID. And then there's other things. So reduced cortisol has been quite clearly shown to be a predictor of long COVID as well. And so that was something that was published in Nature this year, saying that that was one of the predictors for actually developing long COVID. But also the serotonin levels are reduced as well. And other papers have suggested that that links with many of the symptoms that you see with long COVID, particularly around the brain fog and the brain issues. So the list of things that we're finding just goes on and on and on, really. The microbiome in the gut also becomes disrupted, and that's thought to disrupt the gut-brain axis, and that can also lead to both gastrointestinal symptoms, pro-inflammatory issues in the body, but also can cause some of the neurological and neuropsychological outcomes of COVID. So multiple issues that people have, and they've linked with many different mechanisms and different pathophysiology. So very complicated answer again. This is a very complex condition that we really don't understand at the moment.